So let's see how much you've learned and attempt the following answer to the
I
comment
did the
below.
first one.
You did the first one?
The first one is D.
Okay, can you explain me your answer?
Okay, I saw it here. So basically, I did the formula which we usually used it to solve.
So you have to find the mass of the aluminium, and you are given
Yeah.
the current, and you are
Yes.
given the time. Yes,
Yes. Mm-hmm.
and you know this.
Everything is given. I have to, yeah, for the equivalent, I did 27. I divided that by 3
Okay, great.
because that's the balance. And
Okay. So what about the second one? In
in
the
the second one, I did some research, and then I found a statement that in an electrolytic cell, the anode is made from the pure metal, crude metal needing to be purified, and the cathode is from the purified metal.
you did cathode, yeah?
No, anode.
So in electrolytic purification processes, the impure metal to be purified is used as
Anode.
anode, cathode, electrolyte, or salt bridge. No, I said that the electroplating purification, it should be the electrolyte, because you know the substances, the impurified substances are exist in the mixture, and you have to form the solution of this mixture. You have to form the solution of the mixture, and you have to mix that into the solution like this. And then you can purify this in the solution, because the metal ions forms, and then they can attract to the electrodes. Okay, you have to say the electrolyte. So let's go to the next. In the electrolysis of brine, what is a brine, by the way?
I don't understand this question. I
So
sent you.
the
You
brine,
didn't
it is
answer.
the impure water, seawater. It's look like the seawater. The anode must be carbon. Anode must be carbon, because here you provided the 3 reasons, and you have to complete. You provided 4 reasons, and you have to only choose one of them. Okay, because you know I also mentioned the inactive electrodes. What is the role of the inactive electrodes? Can you tell me?
So were the inactive electrodes the ones that put
So Can you tell me what is the role
Like
of the carbon?
the electrodes, were they like the most commonly graphite and platinum were used?
Yes, carbon and platinum can be used. Why? As inactive. Why we should use this? Because the
So they conduct electrons, but they don't take part in the reaction.
yes, they do not participate in the reaction. They just have the redox reaction occur by conveying the electrolytic flow, the current. Did you get it?
Hmm.
So that's why carbon is not a component of the redox reaction. That's why it is not a reducing agent. The chlorine, which is a most likely product, doesn't reduce carbon. I think brine, it is the name of another substance. Chlorine. So carbon is very reactive with the chlorine. It's not also. And the carbon induces the discharge of the chlorine.
If it's an inactive metal, I mean, yeah, inactive substance, and how will it discharge?
Yes, it doesn't discharge the chlorine. This answer is correct. The chlorine doesn't reduce carbon. Carbon do not react with chlorine. That's why. Did you get it?
Hmm.
Induce means cause. Carbon causes the discharge of the chlorine. No, it doesn't. It is just the supplementary for this reaction. Did you get it?
Yes.
Do you have clear idea about this?
Yeah.
And let's go to the third. Corrosion in iron is called what?
Rusting.
Rusting. During the electrolysis of a salt of a metal, current of 0.5 ampere flows for 32 minutes 10 seconds and disposes uh, 0.325 grams of the metal. What is the charge on the metal ion? It's so interesting. We're given this one, the mass, atomic mass of the metal. I like this question, this problem because it's so interesting. You can solve this problem by using only the formula. You can solve by using
So
only,
M is a metal, right?
yes, M is metal.
So there are two masses given.
So your answer is 3.
No, no, no. I didn't give my answer.
So did you get it how to solve this problem?
Wait, I'm reading it again. Deposit means releases or liberates.
So show me the answer and your reasoning. That's it.
I'm asking you, by deposit, does it mean liberates or releases?
Deposit means releases, not evaporate. Evaporation means evaporate. It is a term for the gases.
I said liberates.
Liberates, yes, yes. In that case, liberates. It is a synonym for the deposits. In terms of the electrolysis process.
Do I have to find the metal?
You have to find the charge of the metal. You know the metal because it is 65, which is a zinc. Understood.
No, I don't understand.
You don't understand?
The metal is terbium, right?
I don't know. If I say, you found the answer.
So if the metal is terbium, then the valence is 3.
Don't think about the metal itself. Think about the solution. Alright, so M equal to 96,500 I, what is it, electricity, power, and the T, and also the equivalent mass.
I found all the data,
You found
but
this
I
too?
don't know. The mass is given, the time is given, the current is given. I found the equivalent. What do I have to find? How do I find the charge?
Okay, this one is given. T is also the given mass.
Yes. Current is given.
T, the current,
Equivalent can be found.
the I is also given. And you have to find this one. Did you find this?
I divided, so I found what element is 65.
No, did you find this one?
Yeah, that's what I'm saying. The element with the atomic number 65 is terbium, and the valence of terbium is 3. So I divided 65 by 3.
No, don't think about this one because you came from the periodic table. What's
Yes.
the equivalent mass of this metal, unknown metal? Can you tell me? Did you solve?
By
Did,
65, do I have to look at the atomic number or mass?
so, do you know how to find the equivalent mass? Equivalent mass is equal to the charge or valence divided
Valence,
by
yeah.
this one. It is a molar mass.
Okay.
Molar mass. But you didn't do this. Whenever you
I
found
did
E,
this, but I looked at the atomic number.
atomic number, you don't need the uh, element name. You know, you don't need the element name. You need the valence. That's it.
To know the valence, I need to know the element.
You don't need the element name. You just need the element molar mass, and it's already provided. Did you get my question? Here,
No,
after you found the E, you can put this E here. You can put the 65 here,
okay, now I got it.
and you can find the balance. It should be one of these answers. Did you do that?
I was doing with another way, which turned out to be wrong.
Now, did you understand how to solve this problem?
Yeah, I'm doing.
Okay. At home, you should continue. Now we're gonna move to another problems. So Can you read the problem number 21.112?
The overall cell reaction occurring in an alkaline battery is okay. So how many moles of electrons flow per mole of reaction?
So continue. B, C,
Oh, okay.
D, E.
Okay. If 4.5 grams of zinc is oxidized, how many grams of manganese dioxide and of water are consumed? What's the total mass of reactants consumed in part B? How many coulombs are produced in part B? In practice, voltaic cells of a given capacity, coulombs, are heavier than the calculation in part C indicates. Explain.
So let's do the first one. A. How many moles of the electrons flow through moles of the reaction? So how many in terms of the flow through mole reaction? You can see zinc, zinc 0 and +2. It's losing 2 electrons. 2 electrons. And for for each mole, 2 moles of the electrons, 2 moles of the electrons is gonna be relevant. Did you get it? Because in the redox reaction, the equivalent electrons is 2. The equivalent electrons is 2. Is that clear?
No.
2 mole of the
Give me a drink.
reaction. It means 2 mole of the each reactant. Here, 1, 1, 1. How many moles of the electrons flow? 2 moles of the electrons flow. So, can you solve the B? It's so easy.
Wait, give me a minute. Let me read.
Even the very
If
basic
4.5
students,
grams,
very basic chemistry students can solve this. It's more about the psychometry. So, did you solve this problem? All right. Are you here?
No. I can't even understand what the question is saying. I read it like 5 times.
Why didn't you understand?
I didn't get the meaning.
So, here you can see 1 mole, 1 mole, and 1 mole. 65 and 97 grams of this salt, 18 grams of this water. What about 4.5 x, y? And then you will know the grams of the magnesium, manganese dioxide, water. It's gonna be consumed. Is it so difficult? So multiply 4.5 by 97 and divide by 65, and then you will get the answer. So you can also multiply 4.5 by 18, divide 97, and then you get the answer. Haven't you done such kind of calculations before?
Okay, then what? What's the total mass of reactants consumed in part B?
I didn't hear your voice.
No, I read the next question.
What is the total mass of the reactants consumed in part B? Okay, so calculate the X, Y, and then you can solve the C. Then I will explain how to solve the D and the E.
Do I have to just add the masses?
Yes, you have to add the masses of zinc because here you can see the total mass of the reactants. You have 3 reactants: zinc, the manganese dioxide, and water.
Okay, I found it.
Did you find
Yes.
secret? And can you just class all of them?
Yes, yes. I
And
already
can you
did
tell
that.
me the total mass of the reactants?
12.4.
90.5,
12.4.
12.4. And let's see the D. D says how many columns are produced in the part B. By the way, what is the columns? What do you need the column? Column.
Um, electrical charge or electric. Is it charge?
It is a charge. It is also energy. Yeah? So yeah, zinc is 65, and its valence is 2, and it is equivalent mass is equal to 32.5 grams. Did you get it? And we need if such okay the top is going to if 32.5 grams of zinc produced, one farad in energy is formed. One farad. It means 96,500. It is the energy level, and you have to also find what about the if it is a 30.5 produce 96,500. What about the 4.5? And then you can find the column. Is that clear?
Mm-hmm. Is this supposed to be a very big number?
No, it doesn't. It, it will be smaller than this one.
Oh yeah, small.
8 times smaller.
So I have to find it for all.
You have to find each.
How will I find the valence for manganese oxide?
Balance. You don't need the
Yeah,
balance.
I need to find the covalent.
You have to find the energy. Did you find the X?
So,
All of
yeah, I found that. I already found it. I'm talking about the next one. I need to find it for all, right?
in the next problem, do you mean?
I asked you, do I have to find it for all the substances? For zinc, for manganese dioxide, for water, or only for zinc?
On the last problem, do you mean, yeah?
No, on this problem.
You just making me confused. I just showered this proportion and you just see another ways.
I did this. Look, I did this. And my second question was, will I find this for all these other reactants? And you said yes.
All of the reactants is exact here. All of the reactants are provided. What did you find?
So do I have to find the...
If you didn't find
Okay,
anything, you,
just forget it. Forget it. I couldn't explain my question.
I mean, you asked me such a tricky questions. I didn't understand what you asked me. And
It's okay, let's go to the next.
and suddenly you find the answer, and I don't understand what you
No,
asked.
I don't find the answer. I didn't get my answer, but I don't think it's a
Yes, I
correct
didn't get the
question.
answer because it's illogical. I don't know what you asked me. Because
So
you asked
here, this square that you drew,
yeah,
this whole thing. So this was for zinc, right?
this is for the zinc.
Yes, exactly. So do I have to find the same thing for the other two reactants?
Oxide is how many grams of the magnesium and the, no, you don't need because all of the masses of the substances will produce the same,
Okay.
okay, the same type of number. Just calculate for the zinc, that's it.
Okay, done.
And what should you do for the E problem?
In practice, voltage cells of a given capacity problems are heavier than the calculation. Yes, it's heavier.
So in practice, voltage cells of a given capacity are heavier than the calculation in C. Part C. In
Part C
part C,
was
we
12.4, and for
in the part C we found the overall mass of all of the reactants. And here
12.4,
in the practice, voltage cells of a given capacity are heavier than the calculation in this one. Why? Because you can see here's the voltage cell. voltage cell, and in the solution you have only the sum of the three substances, which is what number? The sum of the reactants?
12.4.
What?
12.4.
12.4? I didn't hear you.
Yes, 4, not 5. 4. 1, 2.4.
Okay. So, and you can see here the solution is heavier. Solution is heavier because it contains lots, massive amounts of water and also electrodes and also the container. That's why it's heavier than the reactant and the total mass of the reactants. Is that clear?
It's heavier because
Because you can see that the solvent, the massive amounts of solvent, the mass of the electrodes, the mass of the container, it counts for the total mass of the cell, which is much more bigger than the ingredients which are dissolved in the solution. Did you get something?
yeah,
Now our time is over. And can you just write down your homework? In our textbook, from page 972 to 979, you have to solve all of the
could you
problems.
repeat? Could you repeat? 900 what?
972 from
Till
979. You have to solve the problems as much as you can. During solving this problem, you have to rely on the concepts which are on our textbook. It means we have to revise, review all of the concepts, understand the techniques, how to solve the problems. That's it. That's what learning looks like.
is this for tomorrow or for Wednesday?
I say solve as much as you can. I'm not giving you the
Yeah,
limitation. Do what you
thank you.
can do till tomorrow. Okay, but during within this week we have to close this topic, electrolysis. Okay, it means you have also the 3 lessons to you need that. If you can finish all of the problems and the concepts earlier, you will we will begin our new topic as soon as you can. Okay, did you get your homework?
Yes.
Now you are free. Sharpen your mind.